We have reached the final section for this topic on transformations, and that has to do with the reciprocal graph. Something to note about the terminology, we call this the reciprocal, meaning 1 over fx. Please do not confuse this with inverse, which is a more specific kind of term that we use on functions, and we will go through that in the next topic. All right, for now, we refer to this graph as the reciprocal 1 over fx. All right, so inside your notes, you have two graphs for comparison over here, and we want you to look at different features of this graph to investigate how the reciprocal function behaves. The first one is going to be about the x and the y coordinates. So if we look at the graph and the points that have been highlighted on the graph of y equals to fx versus the graph of 1 over fx, what we do see is that our y values will change. Okay, so for each x coordinate, its corresponding y coordinates are reciprocals of each other, meaning if this is 6, then I will see 1 over 6. If this is negative 2, I see negative half. All right, I think this is very straightforward because for whatever y value you found earlier, now we will have a 1 over that y value as our new y value. The next feature that we are interested in is the x-intercepts. So how do these coordinates change in the graph of 1 over fx? Can we even find the point? We can't, right? Instead, what we see are two asymptotes at x equals to negative 2 and x equals to 2. Why does that happen? Why does it suddenly become an asymptote? Well, that is because here your y value is 0. So if we take this and put it inside the denominator, what we are going to see is 1 over 0, right? Which is undefined. Okay, so this value is not defined. It does not exist at all. So we draw a vertical asymptote to illustrate that. The next feature that we are interested in is this minimum point, 0, negative 2. What happens to it? We already know that this value will become negative half over here. But in this graph, what we notice is that the point is also a maximum point. So the minimum point has now become a maximum point. We're going to look at another graph and some of the features over there. In particular, we're going to be interested in the vertical asymptote here where x is equals to 0. What happens to this vertical asymptote? Well, it turns out that this is now a root. Can you see that the graph actually passes through the origin, x equals to 0, y equals to 0? So again, we ask ourselves, how come this happens? Why is it that the vertical asymptote becomes a root? So the answer to this is really because my f of 0 is undefined at this stage, right? It is undefined because it is either a very, very high value, a very, very large value, or a very large negative value. So when you imagine something like infinity in the denominator, all right, this value is just going to approach 0. You take 1 divided by a large number, of course it must go to 0. So this is why the graph will pass through this point here and it becomes an x-intercept. Okay, so not going to provide too much explanation in the written form. You can just say that the graph will cut the x-axis at x equals to 0. Finally, the last feature, the horizontal asymptote y equals to 2. I think it is not surprising that it will now become a horizontal asymptote at y equals to half, because this value, if the y values were approaching 2, then when we take 1 over 2, this should be the value that the graph will now approach.